Hello student, this is Shivam Mishra, starting IT of part 3. We will discuss about the inverse of tangent function, or tangent function means tan theta functions. IT of now what we will discuss about the tan theta is a function. Suppose fx is a tan x. We already studied what about fx equal to tan x in class 11th. We know about its graph. Its graph moves like this. This is 0. Here it is pi by 2. Here it is minus pi by 2 in the x-axis. And suppose we are drawing a dotted line over here to find the boundaries of the tan x function. It moves like this. It never intersected with the boundary lines, but it seems that it is going to intersect. Pi by 2 means 90 degree, minus pi by 2 also means 90 degree. Similarly, in the other coordinate also, other curve also, we can find it. Suppose fx equal to tan x, then domain of the function, domain of fx equals to domain equal to r, and range of the function that also will be r. Domain of the function equals to r, and range of the function that will also be an r. And now we are having a function fx equal to tan x, implies that tan x equal to y, implies that x equals to tan inverse y, implies that x equals to tan inverse y, and that means that now the tan inverse function will be just reciprocal to fx function, means now the curve will move in a y-axis and the same limits will be made in a y-axis. This will be pi by 2 in the positive coordinate, pi by 2, and this will be minus pi by 2 boundary, minus pi by 2, and the curve will move like this. It is an inverse function. This curve will seems to be intersect with the pi by 2, but it will never intersect. Here the curve will be seems to intersect with the minus pi by 2, but it will never intersect, and the value of tan inverse function will change. Now you can find the domain of tan inverse x. Tan inverse x equals to r again, and its range will be minus pi by 2 comma pi by 2, and its range will be minus pi by 2 to pi by 2. One more thing we can have a discussion over here, that the principal value in every function such as the sin x, cos x, or tan x, or cot x, sec x, cosec x, the principal value is just its range. Whatever the range we are having of inverse function, that is called the principal value of the function. Suppose this function is tan inverse x, and the principal value of tan inverse x, that is minus pi by 2, y greater than equals to minus pi by 2 less than equals to pi by 2. This is called the principal value of the tan inverse x. Similarly, in the cos x functions, we have got a range of 0 to pi. The principal value will lie in 0 to pi. In case of sin inverse functions, we have got the value range of sin inverse x, that is minus pi by 2 to pi by 2, and its principal value will be minus pi by 2 to pi by 2. Now we will discuss about the next function, inverse cot functions. Now as the tan function moves, similarly the cot one will also be fx equals to cot x. Fx equals to cot x implies that domain of the function fx equals to cot x implies that domain of cot x equal to r, domain of cot x equal to r, and range of cortex equals to r, that is also r, and the curve of cortex functions will move like this, that the curve will be from 0 and it will move like this. Suppose you have the limit of minus pi here, and here it is pi, then from minus pi by 2, here it is pi by 2, it will move like this. In case of cortex, domain of cortex will be R, means all the real numbers. Range of cortex will also be R, all the real numbers. In case of cot inverse x, if fx equals to cot x, fx equals to cot x equals to y, implies that x equals to cot inverse y, x equal to cot inverse y. That means that the function will be just reciprocal of it, and now the curve will move from x to y axis. Suppose here it is pi by 2, and here it is boundary line will be pi, and this will move like this. Now for the domain of the cot inverse x, domain of cot inverse x equals to r. Again we can find that domain is always x-axis found. Whatever the x-axis value we are getting, that is called the domain. This is the x-axis, domain will be r, and range of the cortex, range of cot inverse x, that is 0 to pi. In open interval 0 to pi. And about the principal value, you can find that principal value of cot inverse x, that is y greater than 0 less than pi. The principal value of cot inverse x will be greater than 0 less than pi. Domain of cot inverse x will be r, range of cot inverse x will be 0 to pi, and the curve will move like this. It will just on the pi, and it will be minus pi. From pi by 2 it will change its quadrant, and it will seems like that it is going to intersect the pi value, but it will never intersect. It seems that it will intersect the value pi, but it will not. And the x-axis is all its value, so the domain of the cot inverse x will be always a real number. Now if we are talking about the next function, that is our sec x. Suppose fx equal to sec x. In case of sec x, some curves are very typical. Suppose the domain of the function will be domain equals to r. We have to keep it in mind, and with the proper concentration you need to study about it. Domain of function will be r, and about the range we can say that range of the function equals to minus infinity to minus 1 in a starting with the open interval, ending with the closed interval, union starting with the closed interval 1 to infinity. Infinity always has the open interval, and the curve will be like this. Suppose we are having a value of 0 over here, and 1 and minus 1 over here, and this is the limiting value, means minus pi by 2, and this is the limiting value pi by 2, with the dotted line, both the limiting value will be there, and the curve will move like this. It's all about the value. Whatever the value we are getting of sec x, that is kept in a graph, and we are getting curve that is being represented over here. And now they are trying to find the next curve where it will be, because that is the important one. Here it will be pi, and here it will be boundary line will be 3 pi by 2, and the curve will again from minus value of -1, from here it will move like this. And these all depends upon the value. Again I am saying, whatever the value I am getting, you are getting in the sec x in different quadrant. Because of that only this curve emerges like this, or being found like this in case of fx equal to sec x. Now in case of inverse of sec x, now y equal to sec x, again you are going to get x equal to sec inverse y, and x equal to sec inverse y. Now the first of all we will discuss about the domain of the sec inverse x. And domain of sec inverse x equals to -infinity to -1, close interval union, close interval 1 comma infinity, and its range will be, range is 0 comma pi by 2 union pi by 2 comma pi, and its curve will be, you are having a value pi by 2 over here, pi by 2 over here, and here it will be line of 1, here it will be the line of -1, and here it will have a value of -1 over here, and here it will have a value of 1 over here, and pi by 2. This curve will move like this. Inverse function it is in this quadrant, and like this. In case of sec inverse x, domain will be -infinity to -1, starting with the open interval and with the closed interval, union 1 comma infinity, range 0 to pi by 2 union pi by 2 comma pi, and the curve will be like this. Now the video is getting more longer, so we'll discuss about later. Thank you.